This is a bit different than the perspective that we analyze on this work, because from the work I'm presenting at CITAD, we focus more, let's say, on the applicability, the clinical applicability for clinical trials is more on clinical perspective, rather than on this study that we just published this year. We were trying to get a bit more, to understand a bit more astrocyte contributions to Alzheimer's disease progression, more on the, let's say, pathophysiological mechanism. And it was very interesting. What we observed is that, a lot of evidence from animal and vitro studies already shown that reactive astrocytes can adopt multiple phenotypes. Reactive astrocytes, it's not, as we thought in the beginning, they are not homogeneous. So it's not, it's very complex the way that they respond to pathology. However, the evidence that we had was just based on animal model studies, in vitro studies, and we never had clinical evidence of astrocyte heterogeneity. So what we did, we used biomarkers, we used specifically GFAP and YKL-40 to try to understand the associations with the main hallmarks of Alzheimer's disease, amyloid and tau. And we observed that the different astrocyte biomarkers, GFAP and YKL-40, were associated differentially with amyloid-beta pathology and tau pathology. We found that while GFAP was associated specifically with amyloid-beta pathology, YKL-40 was associated with tau pathology, showing that perhaps, showing that this is the first clinical evidence, let's say like this, of astrocyte heterogeneity in the living human brain. So we cannot simply define, when we do a study, we cannot simply define astrocytes or reactive astrogliosis based on just one astrocyte biomarker. And I think when we talk about astrocyte biomarkers, we always think of GFAP, but it's not as simple as that.